Greetings and salutations, everybody. This is Jacob. There are two blocks sitting on an inclined plane and one free hanging block. Block 2 is connected via a system of ropes and pulleys to block 1, which sits on the inclined plane, and to block 3, which is free hanging, as depicted on the diagram. The mass of block 1 is 1 kilogram. The mass of block 3 is 2 kilograms. The angle of the inclined plane with respect to the horizontal plane is 30 degrees. The coefficient of static friction for the two blocks on the inclined plane is equal to mu s equals 0.4. The question is, what is the maximum mass that block 2 can have before it starts sliding down the inclined plane? Pause the video if you'd like to give this problem a try. When you're ready, put the smack down on the play button. Okay, so how do we go about solving this problem? It seems complicated. Well, it's a little less complicated than it looks. We'll start out by giving a few definitions. Let's call T1 the tension that the string exerts on block 1. Let T2 be the tension the string exerts on block 2. Let T3 be the tension that the string connecting blocks 2 and 3 exerts on block 2. Tension along the entire lengths of all the strings is the same. It doesn't change. Okay, now let's define a coordinate system. Let the axis x be the axis parallel to the inclined plane, and axis y perpendicular to the inclined plane. Okay, now that we got all the definitions out of the way, we can start solving stuff. Alright, let's start out with T1. The force of the weight of block 1 is equal to m1g. Now, what's the string tension, you ask? Let N1 be the force the plane exerts on block 1. The block seems to be partially supported by the plane, but since we're looking for the maximum mass block 2 can have before sliding down, we know the attempted motion of block 2 is downwards, and when block 2 starts moving downwards, then block 1 starts moving upwards. So just when block 2 starts sliding down, the weight of block 1 is entirely supported by the string. So N1 equals 0 at the moment block 2 starts sliding, and T1 equals M1 times G. Okay, we found T1. Now let's go to block 2. Let's call F2x the component of the weight of block 2 on the x-axis. Let's call F2y the component of the weight of block 2 on the y-axis. N2 is the force that the plane exerts on block 2. F is the maximum friction force exerted on block 2 before it starts sliding down. So we have F2x equals m2 times g times sine of theta. F2y equals m2 times g times cosine of theta. Since we want the system to be at rest, then the net forces on all the axes have to be 0. Now where will the friction force be pointed towards? Since the attempted motion of block 2 is downwards, then the friction force will be pointing upwards. T2 is equal to 2 times T1. So we have T2x equals 2 times m1 times g times sine theta. T2y equals 2 times m1 times g times cosine of theta. T3 is equal to the force of gravity which is exerted on block 3, which is m3 times g. So we add up all the forces on each axis, and we have F net 2x equals F2x minus T2x minus the friction force F minus T3, all equals to 0, which is m2 times g times sine of theta minus 2 times m1 times g times sine of theta minus the friction force. The formula of the maximum static friction force is equal to mu s times n2 minus m3 times g equals 0. Now let's find n2. All the forces on the y-axis are equal to 0 as well. So we have n2 plus t2y minus f2y equals 0, which is n2 plus 2 times m1 times g times cosine of theta minus m2 times g times cosine of theta equals 0, which is n2 equals m2 times g times cosine of theta minus 2 times m1 times g times cosine of theta. So we plug that into the first equation and we get m2 times g times sine of theta minus 2 times m1 times g times sine of theta minus mu s times m2 times g times cosine of theta minus 2 times m1 times g times cosine of theta minus m3 times g all equals to 0. And we do the calculations. We plug in the initial conditions in the final equation and we end up with m2 equals roughly 14.4 kilograms. And that's your answer. 14.4 kilograms, which at first looks like a counterintuitive answer. But notice there are 3 forces preventing block 2 from sliding down. And the angle theta is small, it's only 30 degrees. So it's going to take a large mass compared to the other 2 in order to get it to start moving. So yeah, that was an interesting puzzle. We can all rejoice in the marvelous world of physics. Oh yes. And it doesn't stop there. Algebra, logic, geometry, differential equations, calculus, probability, combinatorics, optimization, number theory, chess. All of these will be featured in 99% of puzzles on this channel. And if you have any puzzle suggestions, send them my way. I'm more than happy to feature a problem you suggested. If you like this puzzle, then put the smack down on the like button, destroy the notification bell, subscribe, share the video with a friend at the library, comment down below what you think if you found this puzzle difficult. Alright guys, take care. I'll see you in the next video. Bye-bye.